Hi all, good morning. So today we're going to discuss about, what is exactly big data or what is the reason to go for Hadoop. So basically we're going to discuss two terms. So one is big data and one more thing is a Hadoop. Or we can say that whatever the existing application means. So generally if you observe the applications most properly, sorry, most popularly, so they develop by using Java or .NET, right? So they are existing, these are the existing applications. They are migrating from, for suppose if you go with the Java, they are migrating from Java to Hadoop or from .NET to Hadoop. Or maybe if it is a data ware housing projects or data warehousing related projects, they are moving from data warehousing to Hadoop. Okay, so why they are migrating or why they are moving? So today we're going to discuss this all these things. So before that, so let me discuss about what is the reason to go for Hadoop. So before that, let me discuss a small basic things. So one is what is web application. So the application which is having client server architecture, that type of applications we are calling as web applications. Okay, the application which is having client server architecture. So that type of applications we are calling as a web applications here. Okay. So example google.com or amazon.com like this. Okay, whatever the applications which are accessed from our by using internet. So most of the applications are web applications. Okay. So let me explain you some architecture. So this is the front end in which we're having some fields. And this is nothing but a database, any RDBMS softwares. So it can be Oracle, MySQL, like this. Okay. So this is nothing but we can say that. So here my requirement is just I want to give some values for each and every field. Just I need to click on save. These values just I want to store in this respect to database. Okay. So if you want to design this type of applications, so generally we are going with either Java or .NET, PHP. So many frameworks we have, which is already using to design this type of requirements or this type of applications. Okay, but between this front end and back end, so we're having a one more component called as a server. Okay, between this front end and back end, we're having a one more component called as a server. So it may be some Glassfish, Apache Tomcat. So like this, we're having some servers. Okay. So here my requirement is, so just I want to give some values for each and individual fields, and once if we click on the save, so these values, so just I want to store to database. So once we give some values and once if we click on the save, this request it will go to server, server will communicate to database, and finally values is going to store. Okay, so assume some values it is storing, some Hadoop Hadoop@gmail.com, some mobile number, and some username as Apache, and some passport. So like this it is stored. And once if we this values is stored, so just I want to retrieve these values, I need to display to front end. For retrieving again this response will go to server. Server is going to finally it will display the values. This is a simple architecture. Okay, so what we are using in our software developments or software applications, if you want to design some web applications. Okay, this is a layman architecture simply. Okay, but if you go with your complete for development, so definitely we're having some predefined architecture will be there. Okay, so now if you observe any RDBMS or any RDBMS software, so they're performing two tasks. Okay, they're performing two tasks. One is storage, and one more thing is processing. Okay, any RDBMS software will perform two tasks. One is storage, and after storing the values, so just the software itself need to process that respective values. Okay, so what is the conclusion from this diagram? If you go for any storage platforms, so just if you go with any RDBMS software, it can be Oracle, MySQL, SQL Server, so many platforms we're having. So any platform will perform two tasks. One is storage and one more thing is a processing here. Okay, these are the two tasks which is done by any database. Okay. So let us take some web application, some web application as uh, maybe some Access Bank. Okay, so if you particularly observe this web application, okay, so initially, so they will give some, end user, so whoever using that respective application, so they will give some basic viewing that respective application. Maybe some they will provide some username and password. So just once if you provide your respective credentials, it will log into Axis Bank dashboard, right? So there you can find some transactions, or if you want to transfer some funds. Okay, so if you want to go for some statements, so this type of things initially they will give, but whenever this application development is going on, right, so definitely they will increase the new features or new enhancements. Okay, or we can say that simply new functionalities, so they will go into add within that respective application. Okay, so initially just assume that this is the requirement, this is the function they have added. Just log into the application, and within that they are showing some dashboard, and after that so you can view the how much amount of, how much amount is there in your respective account, and you can transfer the files. So this couple of functionality they have added. That's it. Just assume. So after that, in maybe some 2012 2013, they have added so many things. Maybe some you can apply for credit card, you apply for some, you can apply some loans, some bike insurance. These so many things they have added. So whenever they have added so many functionalities or so many requirements within the same application, so definitely at backend, I mean, if you go for any storage platforms, so definitely they will get huge amount of data. Okay, so let us assume they're using some storage device, a storage platform as some MySQL. They're using some storage platform as a MySQL. Assume that it will store some 1 terabyte of data. How much amount of data this MySQL database can handle? 1 terabyte of data. I mean, beyond 1 terabyte of data, so it was unable to store the data, whatever the data it is getting from front end. Okay, from different sources, we can say that. So assume that they're getting some, so in 2012 or 13 or 12 something, they're getting each and every day 5 GB of data. Every day they're getting some 5 GB of data. And 2014 they're getting some 100 GB of data. Or we can take it as an every year. Otherwise, if you are going for every day, if it is not possible, means you can go with every year. Okay. So in 2016, so even they're implementing some apps as well, Axis Bank app. So yours is going to improve as well as data is going to increase. So maybe some 500 GB of data. So in 2008, currently they're getting some 1100 GB. Okay, how much amount of data they're getting here? 1100 GB. So which was unable to handle by MySQL database. So only reason is, so it can store only 1 terabyte, that is nothing but 1000 GB. So how much amount of data it can handle? 1000 GB. But now we have got 1100 GB, nothing but which was not able to store by MySQL database. If you are assuming as, so it will store only 1 terabyte of data. Okay, so this data, what we are exactly calling as a big data. Okay, this data, what we are exactly calling as a big data here. So this is nothing but big data. It is a problem. Simply we can say that it is a problem. Means, so nowadays we're getting huge amount of data beyond the limitations of our RDBMS softwares. Okay, that amount of data which was unable to handle in our MySQL database. Okay, then nothing but what is exactly big data, it is a problem. So what is the solution for this? So immediately they will go for a solution, right? So here, if you go with this 500 GB or 100 GB, 5 GB or 1100 GB, okay. So assume that this is a total year of data, right? So every 6 months, minimum they're getting 500 GB of data. About 6 months, 500 GB of data. So simply they will uh, copy, or they will copy this data to any one of the ETL tools. So you can assume some ETL tool as a Teradata. Okay, they will store this respective data into Teradata, so which was able to handle huge amount of data. It is also having some limitations. I mean, just assume that it can store maybe some 100 terabyte of data, beyond 100 terabyte, it was also not able to store. Okay, so here, what is the solution they're going to provide immediately for the existing application is, so whatever the data, for suppose today is nothing but, I mean, it is October month. So before October month, okay, till from January to September, whatever the data they're getting, so they will move this complete data to Teradata. Okay, so whatever the real data we're getting, whatever the real time data we're getting, so that data they will store in MySQL. Okay, simply we can say that historical data they're moving to Teradata, and real time data, what for suppose now I'm doing some transaction, there's nothing but real time data. The transaction data only they will store in MySQL. For suppose if a user need to get some statement, so just assume that they need to get some statement on 2017. So for a particular year, they need to get some 2017 statement. So for that, whenever the user is requesting a statement, okay, from the front end, so the request will go to Teradata and it will retrieve the data and it will display to the end user. Because it is a 2017 data, it will not present in MySQL. That complete data itself, it will store in Teradata. So only real-time transactions. So day-to-day transaction only, that type of data it will store in MySQL. Historical data they will fetch from Teradata. That is the immediate solution what they're having. But beyond that, even for suppose if we're getting some 100 terabyte of data, okay. So because banking application, so definitely each and every year they're going to get huge amount of data. This all data they're moving to any of these ETL tools. But at some stage, even ETL tools also was unable to handle the data or unable to store the data. So now if you want to overcome this one, right? So we are moving for a software called as a Hadoop. Okay. So now here we can say that, simply we can say that big data is a problem. Hadoop is one of the solution to solve this problem. Okay, big data is a problem. Hadoop is one of the solution to solve this problem here. There are the what is exactly big data, and what is, I mean, not exactly Hadoop. What is the reason to go for Hadoop? Okay, simply we can say that, for suppose assume that we are getting 100% of data. If you go for data as 100%, okay. In today's world, out of this 100%, 90% of data is unstructured data. Okay, 90% of data is nothing but a unstructured data field. So that is the main problem. Means here whatever this RDBMS softwares, if you are going with RDBMS softwares, so majorly they can store only structured data. So structured data means which is the format here? Simply it will store in the format of rows and columns. That's it. So it was not able to store unstructured data. Okay. So that is the main problem. So what we are facing here. So what are the existing traditional database management tools? I mean this MySQL, Oracle. Majorly they will process only structured data, or they were able to store only structured data. They were not able to store unstructured data. But today, I mean in today's world, 90% of data is nothing but a unstructured data, nothing but audio files, video, or some what we call images. This type of data only we're having use when compared to remaining types of data, whether if you go for a structured, semi-structured, unstructured. Out of these types of data, unstructured data is a very huge. That is a main problem we are facing from this what we call big data. Okay, so why this data is growing fast means every application, if you go with a WhatsApp, okay, so most of the, if you are sending some messages, it is okay, but if you're but daily we are sending so many pics, okay, so many images, so many emergency information, emergency newses or emergency videos, or some comedy videos, so many things we are sending, that is all of our unstructured data when compared to a structured data here. But finally, WhatsApp application itself, they're storing and they're processing. They are not even delaying the data as well. So for suppose now I'm sending a message means within fraction of seconds that message is delivered to the end user, whether it can be any type of data here. Okay, remember what is exactly big data. Okay. So now what is big data? I mean definition. If you go with the definition, it is big data. What is big data? Big data is a word used for a gathering of data sets that are large and complex, which is difficult to store and process by using existing database management systems or traditional data processing applications. Okay, big data is a word, so use it for gathering of data sets that are large and complex, which is difficult to store and process by using traditional data processing applications. So there is nothing but a RDBMS related softwares, Oracle, MySQL. These things comes under uh, database management systems here. Okay, that is nothing but what is exactly big data. Or simply you can say that any amount of data that was unable to store and process by using existing traditional database systems can be termed as big data. Can be termed as big data here. Okay. So now if you go for types of big data. So big data is widely classified or divided into three types. They are, one is structured data, semi-structured data, and unstructured data. Okay, one is structured data, semi-structured data, and unstructured data. These are the types of big data what we have. Okay, so now if you go with the structured data. Okay, So the data that can be stored and processed in a fixed format is called as a structured data. Okay, the data that can be stored and processed in a fixed format is called as a structured data here. Okay, so data stored in a relational database management system is one example of structured data. One example of structured data. So nothing but here fixed format means, so if you observe with Oracle or MySQL, so it will store in a format called as a rows and columns. Okay, so what is a fixed format in structured data here? So it is having a, within this Oracle, it will store as rows and columns. That is the type of data is nothing but a structured data. That is the best example. Okay, so here what are the tables? So if you want to create some tables, we're using some queries. So to create, to retrieve, to delete and update the respective tables. Okay, that is the best example for structured data here. Okay. And what is the next one? Semi-structured data. Okay. Semi-structured data is a type of data which does not have a formal structure of a data model. Okay, semi-structured data is a type of data which does not have formal structure of a data model. Okay, so here whenever you go with a structured data, right? So if you want to store something which is inside of a Oracle database. So first of all, based upon your requirement, we will try to create some tables. Okay, nothing but how we are creating a table means after, once if we are creating a table, within the table we're having columns, so each and every column we need to define, so this is which data type, or so whether it is a null or not, this all these things we need to create. Okay, that nothing but what is exactly calling as a data model. Okay, so but if you go with the semi-structured, so here we don't have any formal structure. So if you observe the semi-structured, best example is JSON. Okay, so if you observe JSON data, so that is a best example for semi-structured data. It does not have any format. So if you want to store this type of data, semi-structured, right? So even though we can store partial semi-structured amount of data, we can store in our SQL databases. But if you're getting a huge amount of data as a semi-structured, so that is also well not suitable. RDBS office are not suitable. Again, we need to go for alternative. Okay, maybe we can go with some NoSQL databases, MongoDB, Cassandra, Elasticsearch. These are the NoSQL databases. Okay, then nothing but what is exactly the semi-structured data. Okay, so now we go with unstructured data. So the data which have unknown form and be stored in RDBMS and cannot be analyzed unless it is transformed into a structured format is called as a unstructured data. So the data which have unknown form and can't be stored in our RDBMS softwares and can't be analyzed unless it is transformed into a structured format. Okay, unless it is transformed into structured format is called as an unstructured data here. Okay, so here whatever the unstructured data we're getting, so that thing first of all we need to make it as in some reasonable format. Okay, some structured format, then only we can analyze it further or we can display to the front end. Okay, so that nothing but what is exactly unstructured data. So best example for unstructured data is audio files, images, videos. So this this type of data or this type of files we are exactly calling as an unstructured data here. Okay, so we're having a three types of big data. One is structured, semi-structured, and unstructured. Structured, so nothing but it is a having a predefined format, so there are nothing but rows and columns. And if you're going with a semi-structured, so it is does not have a formal structure. It forms example is JSON. And if you go with the unstructured, so it simply can say that it is not able to store the data in our RDBMS softwares, what are the unstructured data which we are getting. And if you want to store this data or if you want to analyze further, okay, first of all we need to convert this unstructured to structured, or we need to transfer this unstructured data to structured data. Okay, then only we can go with the further analysis or further complete analytics on that respective data. Okay, so these are the three types of data what we are having. Big data characteristics. Okay, so the file characteristics that define big data are: one is volume, second one is velocity, variety, veracity, and value. Okay, volume, velocity, variety, veracity, and value. Okay, these are the five characteristics that define big data. So here, what are the data we're getting? Okay, so nowadays, if you observe, we're having a separate course called as a data analytics. What is data analytics here? So nothing but what are the amount of data we're getting from any sources, from different sources. So today we're having huge amount of data. On top of that data, we need to go for analytics, and finally it will be benefited for the respective companies or organization, because from that data we're going to get complete insights or complete analytics what is going on in and around that respective data here. Okay, that is nothing but what is exactly, or we can simply say that it is a complete value of the big data or whatever the data which we're getting. Okay, on top of that big data, so they had divided this big data into 5 characteristics. So one is volume, velocity, variety, veracity, and value. Okay,